Hey, I'm Ryan talking with Andre here. He's got some crazy blur thing he wants to show me. I think
Hey,
that's what I'll start with.
hey,
And then you
I'm
can.
Andre, known on the Nim forums as Streetform, and I'm going to show the crazy blur thing that I made in Boxy. And we'll go through the technical details. Isn't that right?
Sure,
Yeah.
sounds good.
Alright, so blur is like a big thing in Pixie that we have. Well, it's a slow thing, right? If you look at the
Yeah,
Pixie code, right, let's bring that up. Pixie code, the blur is kind of like, oh, this is not where the blur is, it's in images.
images. Yeah.
Yeah, images, right? If you look at blur, right, it requires actually like a lot of CPU work, right? Like,
Yes.
and we do this cool thing where we blur everything in the X direction and then the Y direction, right?
Hmm.
Like our first version like blurred everything at once, like with like a matrix kernel thingy. It was like incredibly slow.
Yeah.
Yeah, and this is like great. So I want to do
Much
this
faster, but it's still a lot of reading. A lot of
exactly,
reading.
exactly, and it's all CPU based, right?
Yeah.
Boxy is a GPU thing that we have, kind of like a, not really like a, it's not really like a Pixie for the GPU. It's just like GPU utilities, right?
Yeah.
And I added the blur to it, which I think
Okay.
is cool. This is how it looks like. Let me show you. So this is a blur, so it like blurs it out, and then it like
Yeah.
focuses back in, then blurs it again, right? Just like a bunch of other demos that
Oh,
we have.
sure. It just
We have like
oscillates. Yeah.
the zoom demo and a bunch of masking demos, right?
Yeah.
Yeah, look at that, and that's all powered by the GPU, right? And it's
Sure.
pretty fast, like it's at maximum frames.
Oh yeah. Yeah. I'm sure it.
Yeah,
GPU just
yeah,
shrugs this off
special
like nothing.
exactly for these kind of like workloads. GPUs are like the best, uh,
Yes.
right? It's like it's like weird. Some workloads are much better on the CPU, like discretize and those path walking
Oh
type
yeah.
of stuff. But
Yeah.
GPU just wins at these kind of things, right?
It does. It
Yeah,
does.
pretty cool. Let me see. Let me show you what I did. So first, let's look at the API over here, right?
Yeah. Sure.
So this is the API. It's actually very easy. I thought of different approaches. We have push layer, right, and
Hmm.
pop layer. It has to work on layers. In fact, it will fail if you're not doing it on layers. Just like we have for pop layer. If you try to pop a layer with like a weird mask that doesn't support, right?
Hmm.
Like, well, you can't pop a. I guess you can't use masks if you don't have a layer. But you can't use a blur if you don't have a layer. So if you don't have a layer, it'll just error out. Hey, you're not on a layer, can't blur, because you can't blur the main frame buffer. You don't have like
Yeah. Yeah. It makes
you
sense.
can't read from it, right?
Yep.
Easily, right? Yeah. So it will fail you, right? So you have to be in the
But that
layer.
that's fine. Using layers is really easy. You just push a layer, do your thing,
Exactly.
blur it, pop it onto the frame buffer, and
Yeah,
you're done.
push a
So,
layer, right? Draw a thing, and then we blur a layer, and this is like the API that I just blur a layer and then the radius, right?
hmm.
It is still kind of keeps that push layer, something layer name. I think that kind of works, right?
Yeah, yeah. So pushing and popping is still beginning and ending. You could pop with like a blend mode
Mm-hmm.
parameter if you
Yeah.
wanted, but that's very separate from blurring.
Yeah.
So popping is always blending,
Yeah.
and then functions on a layer, like blur layer, for example, would just apply things to their layer.
Yeah, exactly. I thought about maybe pop layer should take a blue radius in, but I thought
Hmm.
that was too complicated because we need to switch textures around anyways. Like
Hmm.
I don't think it kind of worth it. I think it is good that it's separate.
Pop layer looks very simple there, but it's actually capable of taking quite a lot of parameters,
Yeah,
if I remember.
exactly. Yeah,
And
yeah, the
so it
pop
does
layer.
start to get a little out of hand.
Exactly. Yeah, if
Uh,
you look at what pop layer can do, it's like we don't want like pop layer to do everything. Right? It takes a tint color
yeah,
and
it's
blend it.
tint and a
It's
blend,
actually not
which
that
tint is
bad.
kind of like blending.
Yeah,
Yeah.
it's not that bad.
Anyway, it's fine idea for now.
Hmm.
Like, yeah, looks good.
Yep. Yeah, I think. All right. So let me show you what I do inside the blue layer to make this happen. Right. So blue layer. If you are not on any layer, errors out. Right. We
Makes sense.
flush whatever has been drawn so far. So like we're not because we
Yeah, yeah,
only
because it needs to be we need the pixels, right? Like it can't
exactly
compute
yeah
them.
yeah we don't draw stuff for real until we need to, and this is like our call to draw stuff for real. So it like is in the texture buffer. Yeah.
Yes.
And then I save this layer texture, the current layer texture as layer texture. Actually, probably don't need to do that. This is just like a shorthand. Uh, yeah, and then tint color. So I think I ended up using probably not. Oh, I have to use it for draw UV rects. But anyway, tint color is just white. In
It's
theory,
typically
this
right.
blue
Yeah.
layer could take a tint color. I don't know if it's useful or not. Like it's very easy to pass a tint color here. I don't know if
Yeah.
you need to. I never needed to blur something with a color as well, right?
And then you could tint it right away when you pop layer anyway.
Exactly. So it's like yeah,
So I think
it's
yeah, let's bias towards keeping it simpler.
yeah.
I would say, but that's just my opinion.
Yeah, so then I'm reusing this blend texture that I have for blending. I'm thinking of renaming it to a temp texture or something like that, because I think a lot of
Sure,
these like operations will require like an extra texture that's the size of the screen, right?
sure,
Basically like an
sure.
extra layer for workloads. So I actually want to like this is before we got on this call, right? I was
Yeah.
trying to come up. Okay, do I want to like create a temp texture and then like give it back? Do I just want to have a global temp texture? Probably a global temp texture. Probably just renaming this to temp instead of blend will just work.
Yeah, yeah, because nobody else knows this exists. This is just
Exactly.
for
Yeah,
us.
it's
They
just
interact
internal
with
for
layers.
us. Yeah,
Yeah, I don't think we should allocate and deallocate one the full
exactly.
size of the frame
Yeah,
every single time they do anything for
yeah.
no reason.
Yeah, it's
So,
huge. It's huge. Yeah.
yeah,
So yeah, I just allocated here. I'll probably so this is exact same code as for blend code, right here.
yeah,
Like I'll probably just refactor it out into like a single thing, some sort of
yeah,
temp texture handler, and we'll also do the resizing because most of the time our temp texture will have the width of the frame buffer, right?
yeah,
Of the
because it
window
doesn't
size,
change every
right?
frame
Because
at all.
it like rarely changes, right? But when it does, we need to kind of reallocate it basically.
Makes
Yeah.
sense. Yeah,
Yeah. All right, moving on. Then I do the same trick. I have the blur Y block, the blur X block, sorry, and the blur Y block, right?
okay, so you still do two
Mm-hmm,
passes.
mm-hmm.
Okay,
Yeah, because it's much faster. I
yeah,
remember a long time ago when I was doing that fragment path filler, right? I added a blur to it, and I didn't want to do the two passes, so I did like a single pass. With the kernel where you have like the rectangle that does the blurring, and it
yeah,
was atrociously slow. The two pass system just like wins all the time.
fine,
Yeah,
fine.
actually, one of my first introductions to shaders was writing a blur shader way back, like 15 years ago for Panda 3D. So I know the power of the blur X and the blur Y is like extremely powerful. It's really
Yeah,
slow not doing it.
yeah. There's no reason to do it a worse way if we know of a better way, and it's not even more complicated.
Yeah,
So,
yeah, exactly. So here's how I chose to do it. So we have the blend texture set up. I set up Boxy to draw to the stem texture instead of the current
sure.
layer texture, right? Because
Yep.
what we're going to do is we're going to take the current layer texture and put it onto the temp texture. I set up, the buffer, I use the program, which is the blur shader, which let's look at that later, what the blur shader does.
Sure, sure.
Just
Okay,
like,
so
just
you set
like
the shader up.
yeah, there's a shader. We set up the parameters. We give it the blur radius, and then also this pixel scale because we actually don't know the scale of the texture, so we send that in as well. Well, we don't know this texture. We don't know the scale of the screen, so we send that in as well.
Right.
So that will become important. Yeah. Then we use the shader. Then we draw the full screen rectangle using the uh, I guess here was called the source the layer texture, the current layer texture. So what we're doing is we're drawing the current layer texture onto our like temp texture, right?
Mhm.
With the with the special blur X shader.
Yes.
Yep.
Which
And
means that the pixels we get at the end, drawn into our texture buffer, whatever you want to call it, will be blurred in the X direction.
yeah, exactly. Yeah. Then I do exact same trick. This code is almost identical, right? Is what I do here is now what I do is I'm going to draw back to the layer texture, right? Here we're drawing layer to temp, but here we're doing temp to layer, right?
Hmm.
And I draw to the layer texture. I'm using the blend texture, which is going to become the temp texture here soon, right? Temporary texture, right? I draw it back using the blur Y shader, and it's almost the same shader. It's a different shader, but it's like the code is almost identical to the X one. And then I draw the vertices back, and I don't have to do anything else because the layer texture is the one we want blurred, and it came out blurred.
Yeah,
Right?
so you do a little shader swap here. You draw
Mm-hmm.
into a temp, into the blur X,
Yeah.
and then you read from the blur X
Mm-hmm.
and draw into the actual texture that you want at the end, the blend texture with the draw Y or the
Yeah.
blend Y,
Yeah.
blur Y,
Exactly.
whatever.
Exactly. Yeah. Pretty simple, right?
Yeah, and so then at the end of that though, you've got you've got your blurred image,
Mm-hmm.
but it's not in the frame buffer or anything yet,
No,
right?
no,
It's
it's
still
still in the
just
layer.
in the layer. Yeah,
Yep. And
exactly.
then that's why you have to pop it in order to get it on the frame buffer.
Yep, makes total sense. Okay, yeah, seems reasonable to me.
Yeah.
The reason this is even takes any code is just because we have to just dispatch the draws. It's
Yeah.
otherwise really very simple. It's basically like blur X shader run
Yeah.
with these parameters and
Yep.
blur shader Y run with these parameters. So,
Exactly. Exactly. Yep. Yep. Let's look at the shaders. So shaders are written. I put them in blends for now because that's where all our shaders are. Do you think we should have like a blur nim that has just like this code here in it? I don't know. Or it
uh,
should be some sort of like shader support code. I don't know.
so you have blends.nim inside of Boxy. Yeah, For now, it's fine in blends. I mean, it's not a blend, so
Yeah,
that kind of bugs me a little bit.
yeah, yeah,
But
it is.
like, one problem at a time. I think, let's get all the way through understanding it, and then we'll figure that out. So,
Okay, okay, yeah. So here's how the blur X shader works.
hmm
Maybe it is worth of looking just like the box blur. So this is box blur and this is Gaussian blur, right? Maybe
all
let's
right.
look at box blur first, right? I will comment this out because box blur is slightly easier to understand. And I have that working, so we have here as well.
Yeah, it doesn't apply the decay kind of thing.
Yeah,
Yeah,
it doesn't apply the decay. Yeah. So yeah, let's look at it. So this, for I guess our viewers that don't know, we write our shaders in Nim using Shady, which then compiles it to GLSL. Actually, it compiles it right here.
we can show the
We
GLSL
can
version.
show
It's actually still
GLSL.
pretty readable.
Yeah,
So,
yeah, it's pretty readable,
um,
so that's cool. Yeah, let's me run this one. This one actually will change. You'll get the box blur, which doesn't look as cool, but
yeah.
you.
So Shady is a other
Mhm.
open source library that we've written that transpiles NIM into GLSL. But it also makes it really easy to run and test the NIM code that you've written for a shader on the CPU, which is a huge deal because debugging shaders is a nightmare.
Yeah, debugging shaders is awful. Another thing that it helps me is I don't make these mistakes like switching between GLSL and NIM all the time. Like forgetting semicolons, forgetting how stuff works, using like the incorrect names for things. It's just so atrocious.
Um, it works, but you can see the difference
Yeah,
between
yeah,
the
yeah.
Gaussian because you have the
Exactly,
I don't
exactly.
know.
You can see it's like the blur is a lot more square-ish, right? Like
Yep,
maybe in the middle it's fine, but yeah, like on the edges you can
yep,
see it's just not as great. But it's much simpler to understand. It is still a blur. If you show it to a random person, they'll still say, yeah, it's a blur,
yep,
right? Great.
yep.
So here how that works, right? So I start out with accumulator. I get the blue radius into R, and then I basically iterate from negative R to positive R, right? In integer land, right? And
hmm
then I basically take the texture, right, as I sample it, from negative x to Rx, right? Effectively,
Yeah.
like I'm sampling, right? Maybe here's a little Figma can help, right? So if you zoom in onto thing, right? Can you see the
Yep.
pixels?
I
Yes.
can. Yeah.
Yeah. So like if you sampled it here, it'll just be a single sample, right? But what I'm doing is if I have a radius of 5, right, and as I'm going 5 into this direction, right,
Yep.
and 5 into that direction, so I'm just sampling like this whole thing.
Just to write one pixel, to
Yeah,
be
just
clear, right?
just to write one
Which is
pixel.
why,
Yeah, yeah, yeah. So
which is why on the CPU it's crazy expensive to be doing basically like n reads for
yeah,
every pixel, where n is your blur radius.
exactly.
So
Right. Yeah,
imagine blurring like a 4K image by like 40 pixel blur. Like
yeah.
you're reading
It's like a
a
massive.
biblical amount of stuff.
Yeah, yeah,
So
yeah. The reads are
whereas
just
the
like crazy.
GPU is doing just as many reads, but it's doing them each independently per pixel in
Hmm.
parallel
Yeah,
effectively, and
yeah,
it's wildly better.
yeah. And GPU memory, I think, is way faster than CPU memory, or at least its caches are way faster, right?
Yeah.
Uh,
Yep.
yeah.
Yep.
So
Yep.
that's what we're doing here. We're basically like doing that wedge, right? And then I also use this accumulation. I don't have to. I could just divide by the number of things, right? It's easy to figure out. But I chose to use this accumulator because I'm going to use it later. I start out the accumulator with 0, and then for every texture I read, I add 1 to it. And then at the very end, because this color will be very high now, right? It has all
Yeah,
the
it's in
colors
float
set.
space, but it's way more than 0 to 1, right?
Exactly. Yeah, it's basically 0 to the number of accumulations you did, right? Yeah,
Yeah,
and then I basically divide by the number of accumulations to get like the average color of all those pixels.
yeah. So to be clear, what you just said, you could just divide by like the number of samples you did,
Mm-hmm.
as opposed to keeping track of the accumulator and adding
Mm-hmm.
1 to it. But you're doing that specifically because you'll need it later.
Exactly.
So
Yeah. 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 Yes, that's how the box blur works. Any other questions about box blur?
no.
No. No. Okay.
So
Yeah.
what's the difference between this and Gaussian blur?
Yeah. So Gaussian blur, right? Let's enable that guy. Hide this thing. Yeah. So Gaussian blur does a little bit more, right? So, but it follows almost the same pattern as I start with accumulator. I create the squared radius because I will need it. This is exactly the same as before. You can see, right?
Hmm
But here I'm computing this a, which is like this factor, uh, which uses this formula here that I got from somewhere, right? I actually had to tweak the formula to make it like look as good. I didn't ascend it first, but it's basically getting the exponent of like the squared x divided by the squared radius. The squared radius is just needed here to kind of scale our little like Gaussian circle. Maybe we should start with Gaussian distribution, right? Maybe people don't know what that is, right? So Gaussian blur, Gaussian distribution,
Yeah.
right?
It's just a it's not smooth,
Yeah,
right? It's not linear.
it's just the bell curve, right? Like it's used a lot
Right.
in statistics, right? So I'm just computing the bell curve now of the thing, right? What I'm starting is I start out at x and then I go to other x, right? But I need to multiply it by 2 as well because I want 2 standard deviations, not one. One standard deviation kind of looked bad, so I went to 2. I potentially could go to 3 standard deviation multiplied by 3, so it goes from here to here, but I don't know, it seemed like excessive. We already had 2 standard deviations reading a lot less.
Sure.
Uh,
Sure.
yeah, so that's what I did here. I actually print out the standard deviation when I run it here for testing. With this code, it does nothing for the runtime of the program. It's just for me to test this exponent thing, right?
Yeah.
Is I print out the little hump that it forms, so I can see that it's a real hump and not like broken. Yeah, this code is
Yeah, makes sense. Yep.
completely not needed. Yep. Yep. So then I go in, I add all the, but then I have to know how many of them I did, right? In this case, I start out at -5 because that's the radius it's doing, right? It's like 0.3, 0.2, 0.4, 0.7, 0.9, 1 at 0 because that's like full power, right? 9. At the end, they add up to something like 609 or something, right over here, right? So, I need to basically divide the color right because the highest point is going to be 6 tall basically, so I need to put it back to 1 for the color to make sense to be a color.
Yes. And this is why the accumulator is different than the one above in the box, is because
Yeah,
it's not just n, where n is number of samples. It's
exactly,
actually a
exactly. Here I was just adding 1 to the accumulator, but here I'm adding the kind of this random a value. Well, not random. This kind of Gaussian a value. Yeah. Yeah, so that's what I
yeah.
do,
And
I
then
do.
it gives a much nicer blur, I
Yeah,
think, right?
yeah, yeah. And then I do exactly the same for the y coordinate, the exact same. I think the code is like same. Everything is the same except for like one line. This one, right?
Yeah.
This instead of like this is like adding to the this is the current coordinate we're at.
Hmm.
This one here adds the x, from -5 to 5. But this one adds it to the y, right, from -5 to 5.
Yeah.
Yeah.
And that's also where pixel scale comes in,
Hmm.
because you may be sampling part way through whole pixels if you're scaling it down for some reason or
Yeah,
something like
yeah, exactly. Textures in OpenGL are from 0 to 1, so we don't know the screen coordinates, right? And this basically gets us to screen coordinates. I know what the pixel scale is, so I can transform that into texture coordinates that I use
Yeah.
to sample by.
Yep.
Yep, we can look, and how it looks in here is like we did this, right? But then the y, right, it does it in the other direction, right? It does the y high, right? 5 tall. What? It looks like it just stuck. Here we go.
Oh,
It
it
got
was
unstuck.
just needed a minute, I
Yeah.
guess.
Yeah. So yeah, this is like 5 tall, and then we go 5 in this direction. This is effectively what we're doing. But because we already blurred it, and this is where the power from doing it in 2 steps comes in, right? Because we already blurred in the x direction. I can maybe right. We already did the x, right? When we do the y, we actually are almost equivalent of doing this entire region, right?
Yeah.
Right, which is like super powerful, right? So basically that's like where the full
Yeah.
power comes out.
Yeah, yeah. So, like, another way of explaining it that I think of is, in order to properly know the blurred pixel in the y direction, we need to know all of the blur that ended up as the x
Mm-hmm.
part of that blur. So if you do them at the same time, you have to do, for every pixel, you have to do every single x read and every single y read every time.
Yeah.
Whereas you can bake in the x knowledge
Mm-hmm.
ahead of time in one pass.
Yeah.
So it basically saves you like n-1 times the number of pixels for the x direction across your whole image. Right?
Yeah, exactly. Yeah, we only like read this amount, or
Yeah.
we only read this amount of pixels, right? But it's almost like as if we read the entire block, right?
Exactly. Yeah. And then do that for every single y. So that one gray row, it's like you can then do this. You can do what's on the left or what's on the right for the next one, and the next one,
Yeah.
and the next one,
Yeah,
all
yeah.
the way across your image.
Yeah. The,
It,
the
like,
entire image is doing this,
massively-
right? You're like walking,
Yeah.
like if this was like an image and this is some sort of blur thing, like we're walking every pixel down, right?
Yeah.
Right.
So you can see if you're saving 80% of the work or more, whatever the factor is,
Yeah.
like that's just like it's like an order of magnitude basically. So
Yeah, it's order of magnitude squared.
yeah.
Oh no, maybe not squared, just order of magnitude. Yeah, I don't know. It's different.
A lot. It's a
different.
lot.
Yeah.
Whatever it is, it's a lot. There's a reason people do the two-pass shading.
Yeah.
Maybe there's even some geniusy way out there, but like this works well for us.
Yeah.
So
Yeah, you can actually see what blur X looks like. So this is the blur X. I have it like stored from debugging, right? You can see
Yeah.
that there's no blur on the Y direction. Like this line
Crisp edge.
is
Yep.
crisped, right? But the X line is all like blurry, right? This is the 5 blur. You can actually kind of see where the center is, right? Like blurred in all directions, right? Which is exactly right. And then the blur Y, the other one, right, just blurs that in the Y direction. Then you get.
Yeah. Which is why this is the actual final result.
Exactly, you get like the nice blur, because we basically take stuff that was already blurred and blur it in this direction now.
Yep. Yeah.
Right. So yeah, and that's
Let's see
how it
the
works.
demo now without the crazy artifact lines or whatever you want to call them
Yeah,
from the box.
without the box blur. Yeah. Let's do it. Yep. So this is what it looks like. Yep. Yeah.
And that's a high quality blur right there.
Yeah, it's almost like trippy. Yeah, whenever we resize the window, we have to like rebuild the textures. But look, it's like smooth. I can resize the window while it's going. Some artifacts I noticed is when you get the window really small, it like reads out of the top and bottom of the texture. Probably would need that looked at, right?
Sure.
Because it's
Sure.
kind of
Makes
like
sense.
yeah, I don't know, like you almost have to draw the layer bigger in order to do the good blur.
Yeah, the trap we're coming into there is that we're tied to the frame buffer size,
Yeah.
which is fine as long as it's greater than or equal.
Yeah. But like, it is weird. Like, if you want to blur something, right? Like, and it goes to the edge of the screen, like you just get a worse blur, right?
Which we don't want, to be fair.
We don't want, but it's like, yeah, it's kind of like a harder problem almost.
Yeah, it'd be nice if the size of the layer could be just the size needed for the blur, regardless of the frame buffer.
Yes.
But that brings in more complication.
Yeah,
so it's a known issue right now, but there's totally ways to fix it. It's just, step one is getting a nice blur on the GPU, and that's what this was.
Yeah, a long time ago we talked about the layers having like sizes that you specify, right? The programmer specifies when they push a layer, they give you the size and like the offset they want the layer at. Or maybe pop layer has offset, right? But the push layer has size, something like that.
Yeah,
right?
yeah, exactly. We've talked about it a bit.
And then the blur will work great because you'll know exactly, how far you want the layer, how big you want the layer to be. Yeah.
And there's other advantages to that too. Like right now, it's not a big deal, but allocating a full frame buffer for every layer is arguably like the worst case situation. Many layers might be much smaller, in which case you could do much smaller allocations. CPU doesn't
Some layers
really
could
care,
be bigger, I think. All right, even go the
it's
other way.
true.
Yeah, like the blur one, right? Yeah.
Yeah, but that would be presuming you're literally blurring the whole screen, which can happen. But I think, if I was to gamble, I would say there's probably a lot of layers that might be just like partial screen layers for stuff if you're composing things.
Yeah.
I don't really know though.
Yeah, exactly. We're still experimenting. A thing here, though, and interesting, is that kind of messes with my eyes when I look at it, right? And it goes blur. My eyes want to focus on it, right? But they can't, right? It's like
you got to put your glasses on.
yeah. It's like almost trippy. Like my brain like goes like this is like mess with my brain. This visualization here, like
you wonder if you had
like I almost blink every time it goes like super blur.
Yeah, it's if you had just the right vision problem, I wonder if you would say
no,
this is actually nonsense.
No,
obviously,
no. That's not how optics works. But yeah.
but you can imagine. It reminds me of in VR how they do pre-distortion to like get undistorted by your perception, right?
Oh, maybe.
So I know this isn't that, right?
Yeah.
But what you're saying made me immediately think of the like chromatic distortion thing that they do, which is because it is effectively a bit of a blur at the edges, right?
Yeah.
Yeah. But
anyway. Similar. Yeah. All right. Okay. Close that. What else do we have on this one? Yeah. So I think I walked you through this process.
Yeah. So what would happen from here would be.
I think I do want to move it to its own file, right? So to do move to blur.nim or something like that, right?
Yep. Yeah, and then get it into like a PR form.
And then this one probably to do temp texture instead of whatever.
Yeah, like a work texture that we use for all blends and.
Yeah.
Well, maybe not. Yeah.
Anyway, no, we do use it for blends. Yeah.
If we use it for blends, then yeah. I suppose that's why it's got its name. But yeah, clearly it's doing more than just blends at this point. And then the API like applying a blur to a layer. That really seems reasonable to me at this point. But if you have a better idea, that's fine. And then once we have this merged into Boxy, which is where this lives,
Mm-hmm.
then just to be clear, anybody can add any image they want,
Yep.
and then draw that image into a layer, which is it's very easy.
Mm-hmm.
Apply a blur to it, and then draw it wherever they want,
Yeah.
and they'll get a wonderful blur, and they can blend it in. It'll do alpha blending by default, like the normal blending.
Mm-hmm.
But if they
Yeah.
want some other crazy blend mode, they can have it.
Yeah.
And even tint it, as you said,
Yeah.
in
Yeah.
pop when popping.
Mm-hmm. Yeah.
So yeah,
Yeah. I think
very
this
cool,
was like a
exciting stuff.
small change, but I think it like does improve the stuff we can do in Boxy. Next thing I want to do once we get this blur thing in is look at shadows, right?
Yep.
Shadows are like doubly complicated because you have the spread as well, right?
Yes.
So it's
Yeah,
like,
you do
do
single
you?
color spread, blur, and then tint, basically, right?
Mm-hmm.
So it's like 3 steps instead of one. Go
Yeah,
ahead.
yeah. Should the shadows do like 4 different basically shader invocations, where like spread X, spread Y, and then blur X, blur Y, or should it try to do the spread and blur like in the same
It
shader?
is it is a fair question.
Yeah,
I mean, obviously, less invocations of the shader has its merits, but it's not clear to me that you can synchronize the rights from the blur X in mid shader for the blur Y to make sure it can read them, right? Because you need all the blur X's to be done before the blur Y can
yeah.
be done. So how do you make sure your single shader
Mhm.
can like orchestrate that? Whereas since you do these things separately, you can make sure that that happens. You get what
Yeah.
I'm saying?
Yeah. Yeah, I just think like a spread and blur might be a single operation, right? When we go here into blends, right? Like when I'm doing this A, I'm like, well, look at the alpha, right? If the
Yeah.
alpha is less, then I do one thing. If the alpha is 1, then it's like a spread, right? Which means I do full. I don't know. I know, weird. I guess I'll play and see. But that's the next thing I want to do is the
I think
shadowing. Because what
yeah,
is shadowing?
so
You basically blur in the layer in a specific way, right? Or just blur in the alpha in a specific way, even.
yeah, so um spreading, if I remember right, it spreads even if there's partial alphas.
Yeah,
Does it accumulate the alpha? No, it
yeah,
just puts the max value from the spread.
yeah.
Yeah, so I think you can't do it in a single pass. Well, or at least I'm so
Well, in 2 passes,
skeptical.
X and Y pass, right?
Yeah, because you would need every X would need to know the max value of all the X's
Mm-hmm.
to know the spread value, right?
Mm-hmm.
You could do that, and then it would need to look at all the X's again,
Mm-hmm.
but even the max of the neighboring X ones post spread.
Yeah. Yeah,
So
yeah.
I don't think it can be done. But maybe you'll come up with a smart way. You have
Okay.
feel free to prove me wrong.
Yeah,
I'm
yeah.
just skeptical.
All right. Yeah. So yeah, I guess.
But yeah, this is awesome, to be clear. And yeah, I think shadows would be a wonderful thing to do next, like you were saying.
Mm-hmm. Yeah. The other stuff I also did is I compared the different blurs I get from Figma and our blur. So this is the Figma blur done with the blur here, right? I can change this,
Yeah.
right? Can unblur it, right? And then this is our blur, which I cannot change because it's
Yeah.
a screenshot, right? But yeah, they look like very similar, right? Exactly what you
Oh yeah, I
expect.
can't tell the difference, but I'm also seeing it through like a video stream. So
Yeah. There's
maybe
maybe
maybe you
some
have a better
differences
chance.
here, right? Yeah. And there's another way to blur, which is we looked at box blur, right? And
Yep.
there's gaseous blur, but there's also like bouquet blur, which what cameras do, right? How do you spell that?
Oh, I've never heard the word, so that's all I'm hearing.
Camera blur.
I don't think it's that.
There. I think this one. Yeah,
Okay,
yeah,
here we go.
yeah. So what the bouquet blur does? Well, it's only like for background, but it does instead of using like you see how they're all circles on here, right?
It uses a radius instead
Yeah,
of
yeah. It uses like a circular blur. It uses like a shape to blur, right? Almost like blur with shape, which could be kind of right neat. Uh, but this is like inside real
Agreed.
camera. I guess like Photoshop does its like different thing. But yeah, you see how it does like stuff here. But yeah,
Yeah.
this is more like photo techniques. You know.
So this basically goes for, so Gaussian gives you a bit of this
Hmm.
by doing the decay at
Yeah.
distance, right?
Yes.
But bokeh, whatever, however you pronounce it.
Yeah, I don't know
I've
how to
heard this
pronounce
before.
correctly. Yeah.
It does true elliptical, circular, whatever,
Mm-hmm.
perhaps, and that would give a slightly different thing. I guess it's interesting.
Yeah.
It,
Yeah, if you have a bunch of
given
lights, it gives you like these kind of stuff,
yeah,
circles and
so
stuff. Yeah.
given the Boxy is likely to be used by people producing UIs,
Hmm.
it it I
You
guess
probably don't want this one.
my
Yeah.
yeah, my thought would be this is cool in one side of things, but it may not be what programmers expect when they're just trying to give their box a
Hmm.
rounded rect shadow,
Yeah.
right?
Yeah.
But
Exactly.
maybe it actually looks awesome. I
Yeah.
don't know.
Yeah.
If you want to figure it out, it'd be interesting at least.
Yeah. Yeah. Something maybe too worth playing around with.
Yeah. Because it could also just be a different, you could have blur layer with three options, right?
Hmm.
You could have the box blur if you ever want that for some
Yeah.
reason,
Hmm.
Gaussian blur,
Hmm.
or even bokeh blur.
Yeah. Yeah.
Um,
Potentially.
so, we could do these things. They're possible.
Yeah. Yeah. Well, where would box blur be preferred over? I don't know.
Almost never. We
Yeah.
maybe shouldn't even offer it. It's like
Yeah.
a strictly worse version in all ways. Um, but maybe somebody really likes the effect. I don't actually think we
Yeah.
should go. I'm just saying,
Yeah.
if we go down the route of offering all sorts of different blurs, it technically is an option.
Yeah.
But I think that the best case is that we just have the one blur everybody wants, and
Hmm.
then
Yeah.
nobody has to think about what blur they use because nobody's probably even heard of this. They just want a
Okay.
nice blur.
Yeah. Probably. You're probably right.
But it's still cool. Like I could 100% see someone
Hmm.
doing photo editing or whatever, like refinement to photos.
Yeah.
They might know exactly what they want, but I think they'd be using Pixie and some of its more differenter modes than Boxy, like GPU side stuff.
Yeah. I think Apple does something different for its like background blur. Like here, I think they also like saturate it a little bit and like apply some sort of gray to it, right? It's like a complicated operation. I don't think this is just blur of the background.
Yeah, have to reverse engineer it to find out.
Yeah, I think they call it vibrancy, something like that.
Yeah, if
Yeah,
they just add saturation or something, it's not
yeah,
crazy to
yeah,
do.
yeah. Yeah. Originally, this was like popularized by what is it? In UIs, this blur thing came out like with Windows 7, right?
Hmm.
But like Windows was kind of ugly when Apple did it. Everyone went wow, and that's what really made it popular. Not Windows 7, right?
Well, so to be fair, some of the little things that they might have done would be one, um, they're doing it on a much higher pixel density screen, so these blurs look
Yeah,
better
yeah,
than the
yeah,
old
yeah.
school Arrow.
This is what Windows 7 did. Those blurs, you remember?
Yeah, but they're working with like 4 pixels there, right?
Exactly, right?
Whereas
Yeah,
whereas iPhones have like
yeah,
400 DPI or something compared to the 80 DPI
yeah.
on these old school things. And then the other thing is they may have done the saturation increase to kind of like counteract the fact that when you
Mm,
blur, you get moved towards the average,
yeah,
and it might have just looked a little nicer.
yeah,
So I don't know. I'm not saying Apple really that's why,
mm,
but there's potential reasons.
yeah, yeah, yeah. When they did it, that's when like everyone else like started. Yeah, because you see how blurred that is. Yeah, it's a cool effect, and UIs definitely use it.
Yeah. Well,
All right,
we hope
that's
people who listen to this learned a bit about blurs and
yeah,
how we did it, or how we're doing it so far. You can see the CPU path or CPU version of it in the Pixie repo, and very soon you'll be able to see the GPU version in the Boxy repo on GitHub.
yeah, yeah. Exactly.
All right, thanks for listening.
Yeah. Bye, guys.